principle of capacitor. Let us consider plate A, an insulated conductor. What is that? Insulated conductor. It has the positive charge Q. It has the positive charge Q. Okay. And it has the potential V. It has certain potential V. So the capacitance is given by Q divided by V. Okay, right. Now what we do is, in case B, another plate is brought, an insulated metal plate is brought nearer to the plate A. Then the same amount of positive charges are induced on the other side of the plate B. Equal amount of positive charges induced. So on the left, that is on the inner side, negative charges are created. Okay, so this plate has both sides, On the other side, positive charges are induced. Immediately, the negative charges are created on the other side of the plate B. So, what happens here? Since this negative charge is very close to plate A, it tries to reduce the potential of A. Do you understand? So when you reduce the potential according to this equation, that is C is inversely proportional to V, is it not? So when V is brought down, what will happen? C increases, is it not? So capacitance increases. And you may ask, sir, what about B? B is the plate, the positive charges are on the other side, which is far away. Whereas this is almost very close, because we are talking about the closest distance to between the plates A and B. In this case, that is, now we are earthing the plate B. So when we earth the plate B, all the positive charges are drained. Now it is left with only negative charges. Then what happens? It further decreases the what? The potential. Okay, and thereby, that is, the capacitance increases further. Okay, so when the plate B is earthed, the positive charges get neutralized. Then the potential A, okay, decreases further. Thereby, the capacitance of A is considerably increased. Okay, so this capacitance generally, it depends on the geometry of the conductor and also nature of the medium. Okay, so capacitor is a device that stores electric charges, that we already seen. Now let us discuss the capacitance of parallel plate capacitor with the dielectric medium. We are interested to find out what will happen if a dielectric slab is introduced, a thin layer of oil, we can say, a dielectric insulating material, air, and apart from that air, you have dielectric medium here of thickness T. So T is the thickness of the dielectric medium, or you can say layer. Okay, and now you have three layers, is it not? Air is the layer, then dielectric layer, maybe an oil, and then you have, or mica sheet, something like that. Then you have another layer of air. So you have 1, 2, 3. So totally three layers: air layer, dielectric layer, again air layer. Let me consider the distance between the parallel plates is D, and the thickness of the dielectric medium is T. Okay, now what is the thickness of air gap? D minus T, is it not? Take down. So the thickness of air gap is D minus T. Why? Because D is the distance between the parallel plate and T is the thickness of the dielectric medium. Now, consider this parallel plate. We are charging the parallel plate capacitor, okay, and a positive charge is given, and it has the surface charge density plus sigma. Okay, it has got certain area, capital A. Okay, and these parallel plates are separated by the distance d. Inside we have kept a dielectric medium or dielectric slab of thickness t. So this is the condition, and the plate y is earth. So because of that, there is a capacitance. So now we are going to study that. So the electric field at any point in air, okay, between the plates, any point in air, okay. So electric field. Now let us calculate the electric field, okay. The electric field E, okay. So let us call it air. Electric field in air is given by sigma divided by epsilon naught. Okay, sigma divided by epsilon naught. And dielectric slab, the electric field in the dielectric slab. So that can be represented as, you can put simply E as electric field in air, E dash as electric field in dielectric medium, dielectric medium. Okay, let us represent like this. Therefore, E dash, dielectric medium or slab, you can say. So E slash, simply say E slash, or this can be E simply. Okay, so E dash is equal to sigma divided by, so sigma divided by sigma, and this is the dielectric, I mean, this is the uh, what do you call, the permittivity through certain medium, is it not? And that is given by, you know already, sigma, I mean epsilon r. So epsilon r is the relative permittivity that is given by epsilon divided by epsilon naught. Therefore, permittivity of certain medium is equal to, that is given by epsilon or relative permittivity into epsilon naught. Do you understand? So we can simply put first this one, and second epsilon naught, that can be replaced by this equation. So sigma divided by epsilon r into epsilon naught. Okay, where epsilon naught the permittivity through free space, epsilon r relative permittivity. Okay, right. Then we know potential is given by E into the distance between the two parallel plates. But the thing is here, now it is inserted with some dielectric medium. So the thickness varies, the distance varies, is it not? So in the first case, that is, we can say you had to consider the air column, means you had to subtract this one, and therefore in the first case, that is in presence of air only. Okay, so potential will be E into, instead of D you have to write D minus T, is it not? Because you have to exclude the dielectric medium. Okay, and what about this? That is the potential inside the dielectric medium. So that can be given as what? The we can put V dash, that is equal to E dash into T, is it not? Are you able to follow? So therefore the total potential, so V is equal to, the total potential can be what? The V plus V, that is V in presence of air, you can put air. Okay, so V in presence of air plus V in what? The dielectric medium, dielectric medium. Okay, that is nothing but this V dash. Okay, so we need to add these two. We can substitute the E dash and E suitably. Okay, so therefore the total potential is given by what? E into d minus t plus E dash into t. So we know E is nothing but sigma epsilon naught, is it not? And into d minus t. And what about this one? That is sigma divided by sigma, I mean epsilon naught, okay, epsilon naught epsilon r, relative permittivity, okay. And so we need to add these two, is it not? Therefore, and this is sigma at the t, that is this is the sigma into t. We have to introduce this t, sigma t, okay. And we can take outside the bracket the gcd. So sigma divided by epsilon naught is the gcd, that can be taken outside the bracket. So the remaining is d minus t, is it not? So d minus t plus t by epsilon r, that is the relative permittivity, okay. Now the charge on the plate A, I mean X, the charge on the plate X, let us consider this. The charge on plate X is given by sigma into A. Why? Because we already know sigma is equal to Q by A. So we are interested to find Q. That is nothing but sigma into A. Okay. So that is the equation. This is the charge on the plate X. Okay. Right. Now let us consider the capacitance, which is nothing but Q by V. So that is equal to, now Q is equal to sigma A whole divided by what we have found out here as the total potential, that is sigma divided by epsilon naught. So you had to substitute this equation, okay. So sigma divided by epsilon naught into d minus t, okay, close the bracket, then plus t divided by epsilon r. Now we can strike out this sigma, okay. We can strike out sigma and bring this epsilon to this side. So numerator side. So A into epsilon naught divided by d minus t plus t by epsilon r, relative permittivity. Okay. So that is, so this is capacitance. Okay. So this shows the influence of the dielectric medium. Okay. Now let us discuss about the effect of dielectric. The effect of dielectric. So this is in capacitor, the region between the two plates is filled with what? The dielectric. We can consider mica or oil. Okay. So dielectric means you can consider either mica or oil, some insulating material. Okay. So the capacitance of the air filled capacitor. So when it has only air, no dielectric. So in that case, C is given by epsilon naught or A epsilon naught divided by D. We understand? Right. And if it is filled with the capacitor, I mean the capacitor filled with the oil or mica, okay, so that can be represented as C dash. So now the C dash is equal to, it's given by, that is A into epsilon 0 epsilon r divided by d. Do you understand? Now we can attain the ratio. Okay, we can attain the ratio, that is C dash by C is equal to, so A can be cancelled, D cancelled. So you have, that is epsilon R. So from this it's clear that epsilon R, the relative permittivity, is the ratio between the capacitance with the oil and to the capacitance without oil, that is only air column. Okay, therefore C dash is equal to epsilon R into C. So this is a very important equation.